Hello everyone, welcome to my channel. Let's learn computer science. Hey everyone, welcome back to another video. Today's video is an extension of last video where you learned about logic gates and or not, nor, NAND, XOR, etc. In today's video, you will learn about how do we create logic circuits, how do we create truth table, how to construct logic expressions. So let's begin. So as I said, first of all, we will learn how to construct a truth table from problem statement, from logic circuits, and from logic expression. This is just reiteration of what logic gates are. Basically, logic gates are building blocks of digital circuits, and they perform logical operations on one or more binary inputs, that is zeros and ones, to produce a single output. Correct? So today's topic I'll explain you with the help of some past paper questions. If you look here, this is one question I have picked from past papers. They are asking that complete the truth tables and name the single logic gate that could replace each logic circuit. So this is the logic circuit that is given. Here you have two gates, 1 and 2. This is AND followed by NOT. This is also AND followed by NOT. So this is also NAND gate and this is also NAND gate, right? And there is a working space and a template for truth table given to you where you have two inputs and you need to reach and figure out what is value for X. Now, golden rule here is that never ever jump directly to the answer. Always calculate one gate at a time and use this working space to calculate that, right? If you look here, inputs to this first gate is A and B, and you are getting here some output. You can name it as P, and then this P is getting into next gate as input, and then X is the final outcome. Okay. Now, what you can do is A and B, you can calculate this A and B here, and you can write A dot B, right? And then finally here, because there is a NOT gate, so you can calculate this as P, which is A dot B bar, right? So NOT of AND gate is P. So you can write this here. Next, this P is entering here. So this is P dot P. So you can calculate P dot P here. And then final outcome is X, which is NOT of P and P. I have calculated this. I have just written it here. Have a look. So first AND gate, I have calculated AND first, and then I have calculated NAND, which is A dot P is A dot B bar. Then this P is entering here, and P dot P, which is AND of this. And then, of course, P dot P bar is X. So I have done this calculation in the working space. So let's see, let's have a look. A dot B. So A and B, 0 and 0 gives you 0. 0 and 1 gives you 0. 1 and 0 gives you 0. 1 and 1 gives you 1. Then comes P. Now P is A dot B bar, right? So here, if A dot B is 0, then A dot B bar is 1. If this is 0, then A dot B bar is 1. If this is 0, again this is 1. If this is 1, then NOT of this is 0, right? Next comes this gate, which is AND gate, P dot P. So P and P AND of this with itself. So 1 dot 1 is 1. 1 dot 1 is 1. 1 dot 1 is 1. 0 dot 0 is 0, right? Now X is P dot P bar. Okay, so if this is 1, then NOT of this is 0. If this is 1, then NOT of this is 0. If this is 1, then NOT of this is 0. And if this is 0, then NOT of this is 1. Simple. Now the next question is, what is a single logic gate for this? Now if you look here, outcome X. This is 0, 0, 0, 1. This is exactly the outcome of AND gate. So that is why I have written single logic gate for this is AND. Simple. Let's do one more question where they are saying complete the truth table for the logic circuit given below. So this is the logic circuit which is given. Now, what you need to do here is you need to identify all the gates here. Okay. First thing that you need to look at is that how many inputs are there. So there are 3 inputs. So that means 2 raised to power 3. How many combinations can be built? 8 combinations, right? So you'll always be provided with a blank space, a template where you'll be writing your inputs, your working space will be given, and you'll have to reach to the final outcome. Now, what you need to see here is how many gates are there, how many kind of intermediate gates are there, first of all. So, one gate at a time. This is your XOR gate. So, A XOR B, right? You can name them like PQ, XYZ, something like that also you can name. What is this? This is OR gate. So B or C bar, C naught basically, right? And then this is XOR of this outcome and this outcome. This is XOR of P and Q. That's your final outcome. So you need to identify all the gates, all the intermediate gates, and then one by one step at a time, basically, you'll move forward. That is what exactly I have done here. So if you look here in the gate, you need to calculate naught of C. So I have calculated naught of C here. Then you also need to calculate A, B, XOR. So I have calculated that here. Then next, what you need to see? B or not C. So this also I have calculated here. And finally, whatever you are getting from here and whatever you are getting from here, you are doing XOR of that. So that also I have done. This XOR this, I have written it here like this. That is your X. So one by one, you need to do that. First of all, you'll figure out what exactly you are going to calculate. So that I have already written here. Okay. Now the calculation begin. So this is C naught. So whatever C is exactly the opposite of that. If this is 0, then this is 1. If this is 1, then this is 0. So you will complete this first. After that, it is A XOR B. Now A and B XOR. So XOR is what? If you are having similar inputs, then you get 0 as an answer. If you have dissimilar inputs, then you get 1 as an answer. So that's exactly what I have done. So 0 and 0 giving you 0. Again 0 and 0 giving you 0. Now 0 and 1 gives you 1. Similarly, all the other. So 1 and 1 gives you 0. I have calculated that as well. Now next is this or this. So 0 or 1 gives you 1. 0 or 0 gives you 0. 1 or 0 gives you 1. So you will calculate this complete column. And finally, XOR of this and this. So that means if this is dissimilar, you get 1. If this is similar, you get 0, right? So that's your final outcome, which is X. Easy. Let's have a look at one more question. They have given you a logic expression. X is equals to 1 if A is equals to 1 and B is equals to 1, or B is equals to not 1 and C is equals to 1. So you can also write this statement like this. A is equals to 1 means A. B is equals to 1 means B. And can be represented using a dot, right? So A dot B. Then OR can be represented using plus sign. So I have written here plus. B is equals to not 1 means B bar. So I have written B bar, and to be represented using dot, and then C is equals to 1 means C. So I have written it in simplified way. You can also write it in similar way. And then of course, you have to just create the truth table. So you have to calculate B bar. I have calculated here. A dot B, I have calculated here. B bar dot C, this one I have calculated here. And this is exactly your final outcome. This plus this. So this plus this is your final outcome. You can calculate and you can pause the video and you can just match your answer. All right. You also get questions like these where a problem statement is given and then you are asked to, create a truth table or maybe a digital circuit. Any question can be there. But main thing is that these kind of problem statements are given. So let's have a look. Let's read how to basically understand how to create. First thing is that you need to create a logical expression from this. Okay, so let's have a look. So what they are saying? They are saying that a factory that manufactures cleaning products has a system that monitors conditions throughout the manufacturing process. Now, these are the inputs A, T, and P. These are the inputs. So basically 3 inputs. That means you have 2 raised to power 3 combinations in the truth table if you have to create truth table, right? Then they have given conditions and their respective binary values. Where these binary values will be used in order to create a logical expression as per the conditions given here. So they are saying the system will sound an alarm X. So X is basically your output. So X is equals to 1 if X is equals to 1 if, now if we'll get from here. First is the pressure is greater than equals to 80%. This one. So P is 1. Okay. So this is saying that P is 1. You can either write P is 1 or you can simply write P, because whenever it is 1, you simply write P, and whenever it is 0, you write P bar or whatever input is bar of that, not of that basically. Then there is and. So here and. Then they're saying the temperature is greater than equal to 35 degrees Celsius. Where is temperature? This is temperature, 35 degrees Celsius. So this one. And it is 0. So that means P dot T bar. So this I'm putting in the bracket. Then there is OR. So OR means plus sign, right? Next they are saying the temperature is less than 35 degrees Celsius. So temperature less than 35 degrees Celsius means T is 1. So that means T, no bar, just T. Okay. Next they are saying and the pH is greater than 7. So and dot, and pH is greater than 7 means A1. So we are simply writing A. Hope this is clear. So this is your statement. Either you write this way or you write this way. This is what we have calculated, P dot T bar plus T dot A. This is what we have written here. Okay. Now all you need to do is make the truth table. So ATP, just write the values. These already will be given to you. All you need to do is you need to calculate intermediate values, and then you find out the final outcome. So for intermediate, you need to calculate T bar. We have calculated. Then P dot T bar. This also we have to calculate. Then T dot A. This also we have calculated. And then and then OR of these two. Right? So that is your final outcome. Calculate yourself, match your answers. I hope you'll be able to do it. Now, next is how to construct a logic expression from a problem statement, from a logic circuit, and from a truth table. Now, this is the question which is given. They're saying consider the logic circuit and write the logic expression for the given logic circuit. Do not attempt to simplify the logic expression. Okay. Now, this is the logic circuit. All you need to do is you need to identify all the gates and then you write them. What is this? This is a NOT gate, X bar basically. Then what are you doing? You are doing Y and Z XOR. So if this is Y and Z, so this is your XOR. Here what you are doing, X naught and XOR of this, you are taking a OR. That is your W. Easy. This is what you need to write here. So you can write it this way, not X. This is your not X. OR, this is your OR gate, right? With this, whatever is this. So this is your Y, X or Z. You can write it this way or you can write Y, X or Z or not X. So totally up to you how you want to write it. All you need to do is identify the intermediate logic gates which are used and then reach to the final outcome. Okay. Next is create a logic expression from truth table. Now this is very interesting. In order to create a logic expression from truth table, all you need to do is you need to use sum of products form. Now, what is this sum of products form? All you need to do is you just need to look at rows with 1 as output. So in your truth table, wherever there is 1, you just need to look at that row. Ignore all other rows where outcome is 0. That is your first rule. What do you need to do whenever you have to create an expression from a truth table? All you need to look at the row where outcome is 1 and ignore all those rows where outcome is 0. Okay. So what is your SOP? What is your sum of products form? Consider only the rows where X is equals to 1. Basically, high output means 1 is considered as high and 0 is considered as low. For each row, what you need to do, if a variable is 1, write it as it is. And if the variable is 0, write its complement. Means if it is 0, A is 0, then you write A bar. If B is 0, write B bar. If C is 0, write C bar. Like that. And then join the variables using AND to form the product term. And then all the product terms using OR to get the SOP. Now, what is the meaning of this? What I just said, that first of all, you need to look where 1 is the outcome. Okay. So that means we have to ignore all these rows. We are not to do anything with these. All you're going to do is consider this and work on this. Okay. Now, after considering that this is the row on which we are going to work, you need to look at all the variables which are there, all the inputs basically which are there. So you have A, B, C. Now, A is 1, B is also 1 and C is also 1. What they are saying that if a variable is 1, then write it as it is, A. If it is 0, write it as A bar, B bar, C bar. Okay, but here you have all ones. So you will consider them as A, B and C. Now, how to write it? You need to write AND of all these variables. First thing. Okay. And then if there are more ones. Let's say that instead of this 0, here it is 1, and you're considering this row as well as this row as well. So this row you have written as A dot B dot C, right? But if this row also has 1 as an outcome, so you have A bar, this is going to be your A bar, dot B, because B is 1, and dot C bar. Now, whatever you get from here, then you put a plus sign between the two terms that you have just got. I'll just explain you this with another example. So this is the example. Here, this is the truth table, and they are saying that you have to create a logic expression from here. So first rule is that consider and check where your outcome is 1. So these 4 rows, row 2, row 6, row 7, and row 8. Now, this row is giving you A bar dot B bar dot C. Why? Because A is 0, B is 0, and C is 1 here. So wherever 0, there you will write it as A bar, B bar, and wherever it is 1, you will write just simply that variable. And in between those 3, you'll put a dot. So A bar dot B bar dot C. For this particular row, A dot B bar dot C. That is what we have written here. For this, it is A dot B dot C bar, because C is 0. So that is what we have written here. And for this, it is A dot B dot C. Now you have got individual terms for each row. What you need to do is just put a plus sign between these individual terms. How? Like this. So row 2 is your this, row 6 is this, row 7 is this, row 8 is this. So row 2 plus row 6 plus row 7 plus row 8. That's your SOP, sum of products. And that is how you create your logic expressions from truth tables. Easy? Now let's also understand how do we construct a logic circuit from problem statement, from logic expressions, and from truth tables. Now, logic circuits, you have already covered that when logic gates are combined to carry out a particular function, they form a logic circuit, right? Now, this type of question I have already covered up there. There is one more question here. So, have a look and figure out how to make a logic expression. So, before you create a logic circuit, first step is create a logic expression from a problem statement which is given, and then you create a logic circuit or a truth table, right? Now, here, all you need to look at is this is an input, this is an input, and this is an input. These are the conditions. Make a logic expression. I'll just show you the answer and then you can match it. So this is the logic expression for these conditions. Just match your answer. And then you simply create logic circuit from this. So DST, 3 inputs, so DST, and then D and with S plus T bar. So S and T both have bars, so that is why NOT gates are placed here. Then S bar plus T bar. Then D and this I have calculated here, and then S dot T bar is calculated here, and then whatever outcome you're getting from here and you're getting from here, they are put into an OR gate. That's how you create, and it is of 6 marks. Each correct gate will give you 1 mark. So this is the marking scheme. 1 more mark for each correct gate. And this is the truth table created from the above logic circuit. That's all for today. With this, Unit 3 is over. In the next video, we'll start with Unit 4, that is Processor Fundamentals. Till then, take care. Bye-bye.